Hi everyone, my name is Sanaya. Thank you so much for having me. I'm a software engineer and I've actually been working in the crypto blockchain ecosystem for the last 5 years, so a pretty good amount of time. And that's exactly what I want to talk to you about today. It's about the world of Web3, the evolution of the web, and then we'll do some high level information on what constitutes a decentralized protocol. So let's dig into it. Now, 31 years ago, a British scientist named Tim Berners-Lee invented what we call today the World Wide Web. When the web turned 30, and I'm sure many of you have seen the press that came out of this conference, Tim recently noted, at age 30, this is not the web we wanted. Now, to really dig into what Tim was referencing and to understand what Web3 really means, we first have to take a look into the evolution of the web. So let's take it back a little bit. Before the web, there was the internet. The internet was actually invented in the 70s during the peak of the Cold War between the USA and the USSR. Fun fact, actually, the United States built a decentralized system of many computers distributed across the country solely to combat the fear of an attack that may happen on their existing centralized computer controlling its nuclear weapons. A bit dark, right? But interestingly enough, this is where the idea of decentralization dates back to. Now, fast forward to Web 1.0. So Web 1.0 were the good old days. I mean, absolutely terrible user experience, but it was the days where new browsers like Mosaic and Microsoft Internet Explorer brought the web to the mainstream audience. I'm talking about those like dial-up connection beep, boop, beep, beep days when we would actually surf the internet. Remember that? The beauty, though, of Web 1.0 was that it was decentralized, open source, read-only, but it had the narrative there. Now, all of this changed with the birth of Web 2.0. The rise of the web was largely driven by 3 core layers of innovation: mobile, social, and cloud. Now, with the launch of the iPhone in 2007, mobile internet access drastically broadened both the user base and the usage of the web. Social networks like Facebook, Twitter, YouTube began to really change the narrative, and cloud essentially commoditized the production and maintenance of these applications. As these applications grew and grew, though, we started drifting away from the web's original decentralized vision. Then the idea of Web 3.0 was born. So interestingly enough, Web 3.0 is in many ways the return to Tim's original web, where no permission is needed from a central authority to post anything, as told by the legend himself. It's a leap forward to open, trustless, and permissionless networks. Open in that they are built from open source software, built by an open and accessible community of developers. Trustless in that the network itself allows participants to interact publicly or privately without a trusted third party. And permissionless in that both users and suppliers can participate without a governing body, all powered by the blockchain. Okay, so before I go any further, I feel as though we should probably address the elephant in the room. I'm just going to say it, but the remaining entirety of this talk will now just consist of cute and funny Dogecoin memes. I'm just kidding. I just wanted to make sure this is a halfway check and I still have all y'all here with me. So let's actually get into the semantics of the blockchain. I know it's a word that gets thrown around a lot these days. Decentralized networks, disrupting these current centralized models, offer a very unique potential to support societal fairness, information accessibility, and security combined with business innovation. Blockchain technology is a pillar and a leading concept within decentralized networks, serving as a shared database across the network where information cannot be hampered once stored and verified. Before we delve into the blockchain, though, we really need to understand the semantics on the notion of a ledger. Ledgers have been used for centuries and to record transactions, and they're just that, a record of transactions. A blockchain, quite literally, is a distributed ledger. This distributed ledger is formed by a number of blocks linked together to form a chain. Each block in the chain represents transaction data, and blocks are arranged in a linear sequence over time, forming the blockchain. Moving on. There are three main properties of blockchain technology that have helped it gain widespread acclaim. The first, and I arguably think is the most important pillar, is decentralization. So before Bitcoin came along, we were more used to centralized services. So let's talk about our traditional client server model. When you Google search for something, you send a query to the server, who then gets back at you with the relevant information. This is a simple centralized system. Now, on the flip side, in a decentralized system, the information is not stored by one single entity. In fact, everyone in the network owns the information. In a decentralized network, if you wanted to interact with your friend, then you can do so directly without going through a third party. The next pillar, transparency, is actually one of the most captivating and misinterpreted ideas in blockchain technology today. A person's identity is hidden via complex cryptography and represented only by their public address. So while the person's real identity is secure, you will still see all the transactions that were done by their public address. Truthfully, this element of straightforwardness has never occurred inside a financial context, which is what makes the technology just so beautiful. The transparency aspect makes it pretty much impossible to fake transactions or to engage in any sort of shady business. It forces a level of honesty we have never been required to participate in. The third and final pillar of blockchain technology is immutability. This means that once something has been entered into the blockchain, it cannot be tampered with. The reason why the blockchain gets this property is because of the cryptographic hash function. So in simple terms, hashing means taking an input string of any length and giving out an output of a fixed length. Now, in contexts like you may be familiar with of cryptocurrencies like Bitcoin, transactions are taken as an input and run through a hashing algorithm. Bitcoin actually uses an algorithm called SHA-256. A unique hash is added to every block, and each block is connected to the previous one, as it also contains the hash from the block before it. So it's just like a chain of hashes. The beauty of this, though, is that if any information inside a block changes, the hash of the block changes too. So if a malicious user tried to falsify information, change information, or anything of that sort, the block's hash will no longer match the one reflected in the following block. This is what makes information inside the blockchain difficult to tamper with. So now that you know the three pillars of blockchain technology, in order to really understand how this works, we must also understand how transactions on a blockchain are verified. So in the ecosystem today, there are two main models that dictate how consensus is achieved on the blockchain. The first is proof of work, and the second is proof of stake. So let's first dig into the semantics of proof of work and how that works. The first block in a proof of work blockchain is hard-coded into software, and it's named the Genesis block, also known as block 0. In proof of work, miners, or their computers to be precise, try to solve fiendishly difficult puzzles, mathematical puzzles, in order to be the first to complete a block of transactions. The winning hash is subsequently broadcasted to the network for other miners to verify whether the solution is true or not. If correct, the block gets added to the blockchain and the miner gets compensated with a block reward. Now, on the flip side, let's talk about proof of stake. So proof of stake is a modification of proof of work, but as a means to solve its perceived dependency on energy consumption. And I know this is a topic we're talking a lot about these days. Rather than relying on computers racing to generate the appropriate hash, the idea behind a proof of stake protocol is that participation is determined by ownership of the coin supply. So using a set of factors determined by the protocol, the proof of stake algorithm just pseudo-randomly selects a node, aka a computer, aka anyone who owns the coin, to propose the next block to the blockchain. When a node gets elected, its role is to verify the validity of the transactions within the block, sign it, and propose the block to the network for validation. And then similar to the proof of work algorithm, the staker then gets awarded in a payout in the native token. So that was a lot. But now that you guys are all decentralized protocol experts, let's talk about why Web 3.0 matters. The forthcoming wave of Web 3.0 goes far beyond the initial use case of cryptocurrencies. Web 3.0 will fundamentally expand the scale and the scope of both human and machine interactions far beyond what we can imagine today. These interactions ranging from seamless payments to richer information flows to trusted data transfers will become possible with a vastly increased range of potential counterparties. Web 3.0 will also enable us to interact with any individual or machine in the world without having to pass through fee-charging middlemen. And this is a big one. This shift is essentially going to enable a whole new wave of previously unimaginable businesses and business models, from global cooperatives to decentralized autonomous organizations and even like self-sovereign data marketplaces. The potential and the use cases with this are absolutely endless. Web 3.0 will enable us to interact with any individual or machine in the world without having to pass through this free charging middleman, which is really cool. We can also future-proof entrepreneurial and investment activities by virtually eradicating the platform dependency risks we observe today. So what this means is we can also own our own data and our own digital footprints by using provable digital scarcity of data and potentially tokenized digital assets, which is really cool. And just through the richness of interactions now possible and the global scope of counterparties available, Web 3.0 will cryptographically connect data from individuals, corporations, and machines with efficient machine learning algorithms, leading to the rise of fundamentally new markets and associated business models. And I will leave you with that. Thank you for attending my talk. I'm happy to open up the floor for any questions. Oh, and I did want to mention my GitHub handle is also the same as my LinkedIn handle. So please feel free to add me, message me, tweet at me, and we can chat about everything crypto blockchain.